Hi, everybody. Thank you very much for coming today. My name's Chris Wood. I'm a partner solution architect working for Amazon Web Services. I've been with them for about 3.5 years. Before that, I spent 6 years in the publishing industry, and before that, about 15 years in media and entertainment, mostly as a software engineer, but running teams, developing myself, and latterly with those companies moving to the cloud as well. Since moving to AWS, my role is mostly involved with enabling partners such as BJSS here tonight, who's kindly hosted, enabling their staff, helping them create offerings for the market as well, and adopting new cloud services and best practices. So hopefully some of that I can impart to you today. The title of the talk is Going Cloud Native. It covers quite a wide variety of areas. So hopefully some of it will be of interest, and I'm sure we'll have lots of time for questions afterwards. So let's get started. So I watch Tortoise Media, they do talk shows with sort of cultural experts, and I read this book after a session on Tortoise by this guy called Azar Azim. He's written a book called Exponential, and I thought it resonated with what we're going to talk about today with cloud native and why that might be necessary at the moment. But we're obviously going through changes. We're talking about being in the fourth industrial revolution at the moment, and what Azar was talking about is that there are 4 main areas where the rate of change now is faster than it's ever been before in human history. This is computing and artificial intelligence, renewable energy, energy storage, biology and manufacturing. And so across all of those, a wide number of the customers that we work with and consulting partners like BJSS will work with will be facing the same kinds of issues, which is the pace of change is really fast. Expectations from customers is really, really fast. Now, these are all the reasons why we adopted Agile in the first place those years ago. But now what's happened is that it's so fast that we start talking about an exponential pace of change. Things are getting faster and faster every month. This is reflected in over the years with AWS. These are our number of feature releases. You could count them on your hand to start with. By 2018, we're putting out 2,000 new features every year, and that's increased since 2018 as well. And so think about how do companies keep up with that kind of pace of change? Well, Amazon did it, and are often quoted for doing it on the way that we're organized. We have a culture, and we use mechanisms internally that are part of the group of companies that are known as exponential. And on the top right, sorry, you can see Jeff Bezos's original back of a napkin sketch of how he planned to grow Amazon. And so we call this the Amazon Flywheel. It's also called the virtuous cycle, but it starts with having a customer experience. You drive traffic to your site. That enables more sellers to sell on your site. And then the flywheel continues with that. But as you get more sellers, more customers, your cost base goes down. You can lower your prices, and the customer experience improves. So AWS is the same. We use what we call the Amazon Flywheel, but in an innovation context that you can see here. So we have products. We launch those products, and we get data from customers about how they're using it, what they like, what they don't like. That leads to insights, and then we use those to drive actions to create more products. But the innovation part of that is that as we're developing those new products, we have to form new teams. They have new experiences. They develop new processes to deliver those innovations and those new expectations from customers. And the data, not only about the products that customers are using, but also the processes and how we achieve that, get better and better over time. So it gets faster and faster. Within that innovation cycle, obviously, in order to make that work, though, we have to experiment. We have to get those products out into the testing environment and listen to the feedback that we get, and then iterate on that again and again. And this is where the problem lies if you move too slowly. And this is where cloud native technologies come in. So when I was asked to give a talk about cloud native, I had to be honest, I had to do, it's not a phrase we use too much internally, actually. We tend to talk about serverless and other things, but I had to look up what cloud native actually meant just to make sure I was getting it right. There's a couple of definitions I'd like to share. This is from Priyanka Sharma. Cloud native technology is when engineers and software people utilize cloud computing to build tech that's faster and more resilient, and they do it to meet customer demand really quickly. So what we're talking about there with the flywheel and the exponential rate of innovation. This is the official definition from the Cloud Native Computing Federation's GitHub site. I won't go through all the details bit here, but it talks about technologies and processes that are loosely coupled, they're resilient, they're manageable, and they're observable. And they're combined with robust automation, and they allow for high impact changes to be made frequently with minimum toil in order to achieve that. So that's what we're going to be focusing on today, is how to achieve that kind of rapid change within your software engineering lives. So yeah, here we go. So loosely coupled means small pieces here. So these are some AWS services loosely coupled together, stitched together, rather than monolithic applications. Now, I'm sure I don't need to teach you all about what a monolithic application is, but it's worth talking about why there's still monolithic applications out there and what the advantages of them still are in some cases, that they're easier to deploy. Monitoring and resolution of issues is easier, and it's simpler to understand the architectures, at least to get started. A few years down the line, monolithic applications, there's one person that knows how to maintain a very complex system. In my last company, his name was Archie. He was just approaching retirement for the years that I was there, and most of our efforts actually were to retire the systems that only Archie knew how to do, and they were the systems that managed all of the financial reporting internally for a large publishing house. So thankfully, we did replace Archie's systems eventually, but it was a big monolith that had these problems. The development velocity was low. One release took 18 months to test because of the interdependencies. High chances of failure. Frequently, the engineers would be up all weekend trying to get the thing back up and running, and it's really hard to scale horizontally because you can't separate out the pieces and scale them independently. You have to scale everything at once, which is expensive and difficult to test. So why is it still being used out there? Well, okay, so you want to move to a microservices architecture, something that's more cloud native, but then without the right tools, you have to deploy those on separate servers, call your server team for a server for each service, and you're going to get a pretty bad response from them. So this is where cloud native comes in. Something that's worth pointing out, that cloud native is more than just servers. It's not just about serverless, and serverless itself is more than compute. So when we talk about cloud native at AWS, we think about these three main areas. We do have compute, obviously, in the form of Lambda functions, functions as a service, and also AWS Fargate, which in the container realm enables us to commission container resource to run your containers without having to worry about the underlying instances. But there's also different data stores, Amazon S3 that I'm going to go into in a little bit more detail, an object store that's much more powerful than just a data store. We've got serverless relational database systems, and then other serverless databases like Amazon DynamoDB as well, which is a key value store. And then importantly, we've also got serverless integration as well. So there's no point in creating serverless microservices if the things you're going to stitch them together with are also single points of monolithic failure. So we have a number of different kinds of integration services that don't require you to manage the underlying infrastructure. And we're going to go into those in a bit more detail, so I won't read them all out now. Just to touch on computing though, well, let's start with compute. These are the 4 operating models that we recognize currently. If you want to manage your own virtual instances, then we have EC2 at the bottom. I'm sure all of you are familiar with that. If you want to run containers, we have instance-focused container services, ECS and EKS, where the control plane or the management layer is managed for you, but the actual instances that run the workers or the tasks are you have to manage those instances yourselves. They appear as instances. You have to scale them and worry about the resources running on them. Fargate is a serverless service which actually does all that for you. You decide how much resource you need for your containers, and then Fargate will manage the underlying instances to deploy the right number of Kubernetes pods or worker tasks on ECS as well. And then at the top, we've got Lambda, which is pure serverless compute, function as a service. So I want to really focus on that today. I'm not a containers expert, I have to say, but I'm going to tell you a bit about Lambda. So this is what Lambdas look like at a really high level, or Lambda functions, I should say. They're event-driven, typically. So you have an event coming in, you deploy your code, which can be written in a number of different languages out of the box. You can bring your own language now, and as of relatively recently, last year, we launched the ability to run containers within Lambda functions as well. You can run it, you can package a Docker container and deploy it onto Lambda. And within that function code, you can call AWS services, write or read from databases, and do anything else you need to do that the language will support. From a customer's perspective, it's a little bit more complex than that in reality. You've got the Lambda code that you bring yourself that we talked about, and configuration for the Lambda functions. You'd have to define the functions themselves. And then there's a couple of ways that you might call those. You can call them through asynchronously or synchronously yourselves, or you can map them to other AWS services and have that integration done automatically for you. We're going to touch on that a bit more in the future. And then for each Lambda function that you define, those are versionable. So each time you change the code, you can change the version on it. And you can also define the concurrency of those Lambda functions. How many execution environments are there going to be available for requests to run those functions? From the technical perspective under the hood, that looks like this. So if you're an end user calling those, you can call them asynchronously or synchronously. You can, or as we said, you can map them to other services through this event source mapping. Either way, they go through a Lambda front end. For asynchronous Lambda calls, they go through an internal queue. And then we have a number of workers which are all running in micro VMs based on our Firecracker virtualization technology. And this basically allows us to spin up new execution environments extremely quickly and reduce what used to be a problem for us, which are Lambda cold starts, and really reduce the size of that functional unit down to extremely small levels. So we talked about those different invocation modes, synchronous, asynchronous, and event source mapping. Let's look at those in a little bit more detail. So typically, if you're going to be calling it synchronously, you'll probably want to write a Lambda function but expose that as an API. Otherwise, people have to actually have permissions to run the Lambda function through internal AWS IAM roles and things. So you can expose those Lambda functions through API Gateway, which will enable users to make a synchronous call to the front end. That will execute on the next available execution environment and return back to the requester. And those are throttled based on the concurrency limit that's set for that Lambda function. Mostly though, if you want to scale out, you want to be calling those services asynchronously rather than synchronously. So you might have a service like SNS or EventBridge that is routing larger numbers of messages through to your Lambda functions to do some work. In that case, they still go through the front end, but they get internally queued within the Lambda service. And then the same execution environment is used, depending on your concurrency, to execute to fulfill that request for each of the messages on the queue. But then obviously all the original requester gets back is acknowledgement that the function has been accepted, or the request has been accepted for execution. And so you really need to manage the state of that externally outside the request response. In that case, you might want to manage things like dead letter queues in order to manage the messages on the queues that you've used to call those Lambda functions. Otherwise, you're not going to have those functions execute successfully. So event source mapping is where actually a lot of AWS services can be directly linked up with Lambda functions to execute stuff. So examples of that, DynamoDB. We have a service called DynamoDB Streams, where for each change on an item in a DynamoDB table, that actually gets pushed out onto a stream of immutable changes. Those changes can be batched up and pushed to Lambda. Actually, I say push to Lambda. With the event source mapping, that mapping actually pulls those changes from DynamoDB's change queue and then executes them in batches, ultimately one by one. So that's the same with services like Kinesis or MSK, our managed service for Kafka too. The event source mapping will pull the requests from those services that are outstanding, execute them, and actually those are executed synchronously, so the services can get instant feedback. Some sample architectures running Lambdas. As we mentioned, typically you might want to front a Lambda function with API gateway. Also, we have a service called AppSync, which is a managed GraphQL implementation. So Lambda is often used as a resolver for API calls, for query calls, for example, to APIs, or to mutate, i.e. to update data through the API as well. And step functions, the actual steps within step functions can be executed through Lambdas too. So those are all synchronous examples. In the asynchronous world, I'm going to tell you a bit more about EventBridge in a minute, but SNS and EventBridge would be key players there. So we're talking about queued asynchronous execution. And then with the event source mapping, we talked about DynamoDB, but you can SQS, which is a queuing service. That's actually a kind of point-to-point integration. So there's an event source mapping available for that, and Amazon MQ, which is ActiveMQ, RabbitMQ, a few other queuing technologies as a managed service too. So some best practices about when you're writing Lambdas. Firstly, observability. So you've adopted a microservices architecture. You've created a large number of small units of business logic and function. You've maybe put APIs over the front of that with API gateway, but you've now got hundreds, maybe thousands of these Lambda functions defined, and they may be calling each other directly, or more likely calling each other through asynchronous queuing. How do you track all of that? So you have to manage observability. So we have a service called X-Ray, which you can inject into your code. That will allow you to see the full life cycle of those requests throughout the different set of Lambda services that they would call. Another best practice is to make sure you implement structured logging, not just standard logging coming out of the language that you've chosen. So you can do structured logging as well as create custom metrics using CloudWatch logs EMF. So that's CloudWatch logs. It's not enhanced metadata format, in embedded metadata format. So you can essentially define JSON logging and metrics as JSON messages instead of standard sort of grok type textual logs. And that really helps. You can then slice and dice that within CloudWatch and use it to alarm when there's problems, and get much richer information about what's going on. For a certain number of languages, these tools are available and wrapped up through Lambda Power Tools, so it's worth checking those out if you haven't used those before. Secondly, error handling. How you handle errors is going to differ based on whether you're calling asynchronously or synchronously. But if you're doing synchronous calling, then obviously the error is going to be returned straight back to the caller. But if you're doing asynchronous calling of Lambda functions, you're going to need to think about setting destinations for failures for the Lambda function. And if you're doing a event source mapping for SQS, the queuing service, best practice is to set up a dead letter queue, which is a feature that launched relatively recently. And for other event source mapping, the error destinations really depend on what service is mapped. In terms of functional optimizations of the code itself, one thing you should try and do is not initialize all of your resources within the actual Lambda handler. So within the function definition itself, you'll have a method that's defined as the handler and maybe some helper methods, but don't initialize all of the resources within the handler method, because that will be called every time that the Lambda function is executed. So try and initialize them externally. Also, it's kind of common sense, but minimize the size of your deployment package to only include the dependencies that you're actually using. And opt for, if you've got choices, opt for dependencies that will load quickly as well. And all of that will improve the startup time for those Lambda functions. Okay, so we've talked about Lambda. We mentioned some queuing and asynchronous patterns as well. And this brings us back to event-driven architectures. And so the main objective here is to abstract the consumers and producers from each other and reduce the tight coupling between different functions and services. So that overall should improve the responsiveness, make them more extensible, and ultimately give you the ability to buffer messages to manage your resources more effectively as well. I always like to think about event-driven, sort of a bit of a sliding scale. On one side, you've got sort of what you might call message-based event-driven architectures with larger messages, with maybe richer data in, all the way to streaming messages on the other side, where you're really talking about smaller atomic messages, but maybe at much higher volumes. And in those circumstances, you're not necessarily dealing with each message at a time. You might be dealing with those messages in the stream in aggregate. So maybe creating rolling averages, maybe wanting to go backwards and forwards through the data to replay those messages, which is contrast with actually dealing with one message at a time. And there's the choice of services that you use will depend on what your objectives are in that area. In terms of messaging, this is from Tim Bray, an ex-AWS distinguished engineer. If your application is cloud native or large scale distributed, and it doesn't contain messaging components, then that's probably a bug. But which services do I use? We mentioned there's a sliding scale based on how real time, how high volume, how small increments those messages are coming through on, or are they actually sort of business transactional focused messages? Well, this is a bit of an attempt to create a flow chart. I'm not going to go through all of it, but essentially, if you're dealing with IoT, then you should be using IoT Core, and we have a whole suite of IoT services that I'm going to touch on in a moment. But your first port of call, at least, should be IoT Core, because it's deal with the protocols that IoT needs to deal with, and including security and things like that. So if it's IoT, have a look at IoT Core, and it's got its own internal message requirements and capabilities. If you're building a new service, and then you need to start thinking about whether you're messaging or streaming. And in this case, you're going to end up using some more pub/sub message focused services like EventBridge and SNS and SQS. On the other end of the spectrum, you'd be talking about Kinesis, or maybe it's not serverless, but as a managed service, our version of Kafka MSK as well. So I'll be distributing the slides to anybody that wants them afterwards, but this is an interesting way of making those choices. And on the other side, we've got more managed services all the way down to EC2. If you really need to run a specific type of messaging platform, then you can run it yourself on those instances. But today we're very much focused on the left-hand side on the serverless services. Specifically drilling into SNS and SQS. So SNS is basically a notification service, but it's a publish and subscribe service. So you can create multiple subscribers to a single topic. And it's often combined with SQS, our queuing service, in order to create a kind of more traditional topic-based publish and subscribe fan-out architecture. So you could have a Lambda, for example, that pushes onto SNS. That might then create a message in 2 subscribed queues in SQS. And then for each of those, you might have another consumer of those queues. So that's fanning out. And then you can also combine messages. You might have a couple of message producers on the left-hand side pushing into SNS. But both of those SNS topics are subscribed by a single SQS queue. And then you can then use another service to pull those messages off. So you combine data from multiple services. So that's fanning in and fanning out. It's a good pattern. SNS and SQS are typically used for really high volume. I mean, you can use them in many scenarios until there are more choices. It was the go-to for most messaging, but now we have another service called EventBridge. We tend to use SNS and SQS for highly scalable, high volume, but very similar messages. So, for example, you can filter messages within SQS based on metadata, but that's about all. Whereas with EventBridge, you can actually start to create rules and do filtering based on the actual content of the messages themselves. So for general business use, EventBridge is now the main service that we'd be recommending for messaging, whereas SNS and SQS really good for as we said, high volume, high performance workloads. So let's touch on EventBridge a bit. EventBridge, as I said, is a classic message bus, message broker. So it enables you to take events in from the left-hand side. Those messages are put onto topics, and then you can create rules in order to take the messages off the topics and execute downstream functionality. There's a number of different types of message sources, AWS services. In fact, EventBridge is a rebranded naming of CloudWatch events. It was originally a CloudWatch alerting mechanism, but it's been generalized now, so you can hook up to many AWS service events through CloudWatch style events, but you can also create your own custom events. And we're also now we've created a bunch of connectors, so a lot of SaaS apps can hook directly into EventBridge as well. So things like Zendesk would be a great example of that. Every time a ticket is raised in Zendesk, it will raise a message within EventBridge, and on a topic, you can then set up rules to distribute that downstream to a number of people that might need to deal with that. And obviously, some of those rules and message consumers can then put messages back on other topics. So you can use it for a complete event routing system for your architectures. A quick example of who's used this: Lego actually based their entire consumer ordering site on that, following a big Black Friday crash in 2017. They've moved to entire event-driven architecture with EventBridge at the heart of it, and funnily enough, they've not had any major crashes since then. Okay, so I wanted to talk a little bit about serverless and the shared security model. Some of you might be aware of the AWS security shared responsibility model. Usually it looks like this, or traditionally it's looked like this, where AWS look after the cloud itself, and our customers have to look after what they put in the cloud. So what that means, we look after the infrastructure, we look after the management layer and the governance layer and the security of the compute, storage, database, and networking. But if you spin up an EC2 instance, you have to manage the patching of the operating system, you have to manage what you put on there, you have to manage the encryption of data at rest and in transit for as it moves between your services. Well, with the serverless model, that's actually that's very different. We actually look after all of that stuff around managing the services. So the platform management, encryption of data at rest as it's being used by the services or within the databases, if we're using serverless databases, all of the network traffic and routing, as well as the operating systems and patching and all of the hardware and everything that goes underneath there as well. So essentially, you don't have to deal with that. I promise I wouldn't mention undifferentiated heavy lifting tonight, but that's a good example of it. At least I managed to say it properly. Next, wanted to touch on some cloud native data stores. We mentioned DynamoDB before in terms of streams and hooking those events up to Lambda. Another big change about cloud native is how you use databases. And traditionally, you may have one big database, usually an RDBMS database that everybody uses, and it would scale out typically vertically, meaning it got bigger and bigger and bigger. That doesn't really work with cloud-based architectures. Also, as database technologies have evolved over the last few decades, specialist databases have emerged, and within a corporate environment, it's often been very difficult to reconcile the one big Uber relational database in the heart of your business with the kind of the functional databases that you might use. And so within the serverless realm, we kind of flip that entirely and encourage people to use exactly the right data store that they need for the service that they're using. And here's some examples of the database technologies that we would typically recommend. So DynamoDB is a key value store for high volume, high throughput, low latency storage and retrieval of keys and values. If you really need a relational database system, we have an Aurora technology that's Postgres compliant, and that's now has a serverless version of that as well. So it will scale up according to your needs without you having to manage the underlying instances like traditional RDS. If you have to use RDS, we have an Amazon RDS proxy now, which is it will cache queries on the database, and that is actually serverless, and so it will scale with your application requirements and take a load of load off the RDS databases in the background. Quite recently, we relaunched Amazon TimeStream, which is a time series database. So essentially, you have to. It's limited in the schema in that you have to provide a timestamp and some dimensional information within your puts, and then you get to query that on a time series. So it's kind of sits between what used to be used by DynamoDB and a lot of Internet of Things use cases, for example, for streams of telemetry. Kind of sits between there and a kind of Grafana type database, or at least the ELK stack, for example. I want to talk about S3 as well. So S3 are object storage, and most people know about that, but lots of people don't know about some of the more advanced functions of S3. So for one, you can now select data direct from S3. So you can do a query on an object within S3, a file. If it's in JSON or CSV or Parquet format, you can query a subset of that file without actually having to pull it into a database or pull it out of S3. So that will really reduce your data out costs if you're pulling large amounts of data from S3 into outside AWS, for example. The second really neat feature is object lambdas. So for S3 gets, where you're getting an object out, you can also run a lambda before the object is returned back to the requester too. So that's really good for obfuscating PII data, for example, if you're storing people's personal data, or for if that data, for example, is actually an image file, you can return a thumbnail that's been generated on the fly by Lambda. In terms of managing the lifecycle of data, we've got intelligent tiering now, so it will move from frequent access to infrequent access to archive to deep archive without you actually having to do anything. And now we recommend, because the costing structure has been changed, we recommend that intelligent tiering just be switched on because it will save you money pretty much in all circumstances. There's a couple of circumstances where it wouldn't, but they're very niche. And then lastly, multi-region access points with S3. You can now create an endpoint within S3 for S3 buckets, object buckets that are regionally replicated with a single endpoint that will use the Amazon network automatically without having to change the endpoint. You don't have to point at one region's bucket versus another. You just point at the endpoint, and it will return the closest, the object that's stored closest to you. And then finally, you may not know about Amazon Athena, which is a Presto-based technology that can again query Amazon data direct without pulling it out into another database or a data store. So you can run full SQL queries over data, and actually over data that's in multiple files as well. So you might have structured log files that are just building up and up over time, and you can go in and run queries based on that data just to pull out the error events, for example. So again, really neat, and that's being used a lot for data discovery, especially for machine learning, for example. I'm well over time, so I'm gonna speed up a bit and skip towards the end. What I wanted to mention was with cloud native, it's not just about the technology, it's about the processes and the way you work as well. So there's a number of accelerator tools that you should look at if you're not looking at them at the moment. Serverless application model is an accelerator for developing serverless applications. It works for a subset of services, but will manage the definition, the packaging and deployment of those within the AWS environment. CDK is a cloud development kit that enables you to create cloud objects actually within a number of programming languages rather than developing those in CloudFormation or in Terraform yourselves. And then there are other third-party infrastructure accelerators as well, like serverless.com, that can make your serverless development really quick, really easy. Development accelerators, you should look at Amplify if you're not looking at it at the moment for front-end development. Where you're using AWS backends, it has front-end libraries, templates to quickly get your mobile and web applications up and running very quickly, supporting frameworks like React, Vue, Amplify, and some mobile technologies support iOS, Android, as well as React Native as well, and really gets you up and running very quickly to add things like security and backend databases in without you actually having to do any coding, or at least it will create the boilerplate for you to then modify. And then platform accelerators, it's worth mentioning AWS Proton, which launched last reInvent last December and is now GA. Proton is described as a platform for building platforms. So it takes the templating and infrastructure as code to another level. You can define an entire environment for a developer. So we talked about increasing the acceleration time of innovation and prototyping. Rich before asked me if I had access to unlimited AWS accounts, and yes, I do. And I don't know how I could do my job without that. Proton enables you to define templates for entire environments, which might have a whole number of services, maybe some Fargate, a few databases, a Kickstarter for a software development team. And then on top of that, define services in order to deploy into the environment. So basically, it blurs the line between the developer or the builder and the operations team. So previously, maybe your developers would be building software. They would define a Docker container, a Docker image for that, and then the infrastructure team or your operations team would then deploy that for you. But this blurs the line. It allows two teams to work much more closely together in a more cloud way. I was going to touch on serverless IoT. Most of our IoT is actually serverless, so go and have a look if you haven't. Even for mobile applications, IoT is becoming more and more relevant. It's actually, to get data in, it's often much more cheap than using API gateway, for example. If you can use MQTT protocol or MQTT over HTTP, then it's really good way to get data in, and from there you can distribute it out to other services. And the ML stack, for developers now, we've got a lot of AI services, we call them, but pre-made ML services that developers can just use. Okay, so things like recognition to pull objects, to do object detection out of images. There's a lot of natural language processing technologies to extract entities out of text. All the way through to forecasting and personalization. All of that's available without actually having to think about the underlying infrastructure. You just call the APIs. Okay, and my final message is just try it out. All of this stuff is available. A lot of it's on the free tier. Go and have a play with it. And thanks for listening. There's my LinkedIn details. If you've got any more questions, feel free to follow up. So sorry, I've drastically overrun.
No, not at all. It's great stuff. Thank you very much, Chris. Really enjoyed that, and it was great to see the various architectures that we can build with some of this fun tooling. So now I'm going to invite Tim Antrobus up to the stage to sit with us, and we're going to have a little bit of a conversation. And just hear about each other's experiences with some of this tech. We've also got some panelists joining from online. So we've got Mike Winter and Ryan Little from BJSS, who will also be talking about some of this stuff. Not necessarily AWS focused, but I think it's good to sort of explore about what some of the things that you can be building with this exciting tech, and how there might be different opportunities by using other platforms as well, and how maybe you can get them together and all that good stuff. So Tim, do you just want to share about some of your experiences with some of these serverless technologies and how that's helped you?
Yeah, sure. I've got on mic here, I think. Yeah, well, thanks for having me. So I've worked mainly with Google Cloud Platform, so the enemy. But long story short, it's interesting, you know, through your presentation, Chris. So many of those services, there's lots of parallels and similar offerings. I think my experience with serverless has been that pretty much like Chris a little bit. You know, I've got a history in app development, working with teams across a range of different industries, and I think what appealed really about serverless, particularly on the sort of Google Cloud front, was that it lowers the bar of entry in many ways to access a lot of really fundamentally quite important technologies. So if you're working within an existing environment, sort of pervasive eventing, for example, is difficult. It's difficult to achieve. You know, there's all sorts of cross dependencies, and that's one of the great wins, I think, of moving into a cloud native environment. I think servers lets you do that and dip your toe into it, and it promotes experimentation. You know, you can start composing different services together, whether it's PubSub or you know, IoT sources or whatever. You know, functions as a service, or Lambda in the AWS space, and cloud functions in the Google space. And so I think it begins to open up possibilities. I mean, for example, in an organization I worked at previously, we made use of a managed cloud database called Cloud Firestore, which comes with a very rich eventing layer, a very rich eventing model. And it began to transform not only the sort of initial kind of strategic design approach we'd taken, but it began to open up approaches that we hadn't even considered. And it let us do things that just weren't possible before. So that was wonderful, being able to sort of piece together these composable architectures, these flows. And it certainly helped us introduce new ways of doing things, which address some long-standing problems with some of our mobile apps, for example. So yeah, worked with messaging, serverless messaging mechanisms, also sort of, queuing and eventing. And it's interesting, particularly on the Google front, I think, it's somewhat pointless in some respects to sort of try and do the sort of, this platform's better than that platform. I think they've got different emphases, really, different focuses. And what I particularly was drawn to on the Google front was the great developer experience. It's this pervasive focus on a great developer experience. And that may sound like a frivolous thing to mention when you talk about adoption. But if you look at the current situation where there's a huge war for talent across all sorts of different organizations, and the pandemic and lockdowns across the globe have driven digital transformation and digital adoption, then your developers and your engineers are just worth their weight in gold. And so, optimizing for developer happiness is not a trivial business goal. It's really important. It's critical. So I think, I would sort of echo a lot of Chris's points that these technologies are very open and accessible. The platforms have quite generous free tiers. You're able to experiment. You can dip your toe in and begin to piece things together. It's great for things like little technical proof of concepts. And I think, if you're in an organization that's somewhat lukewarm about the cloud, serverless is a nice way to go in. And if you're a dev team without a strong DevOps component or a well-established SRE group, then serverless is somewhat of an easier path. And you can follow this sort of evolution. You can move through some of the more managed products, and as your skills or as your organization and your team grow, and you become more sort of, your expertise grows, then you can move into more of the sort of custom managed stuff yourself. So I think there's a nice glide path there. That's what I'd say. Yeah,
that's great. Thanks very much. And Mike Winter, you're on the call. I work with Mike quite a lot. Do you have any thoughts or experiences there? I know that you're probably, you've done AWS and Azure, but you're kind of our Azure guy when interviewing folks and whatnot. But what's your thoughts?
Yeah. So hello everybody, and yeah, thanks for inviting me on, Rich. I think my experience, obviously, of serverless, I've been involved now probably 3 years on serverless technologies in the various different clouds, or at least the AWS and the Azure clouds. A couple of those were booking systems. One was a booking system for National Health Service. Other was a booking for a high street opticians, and they're large throughput systems. So they're like thousands of bookings, kind of a second systems. I think what's really surprising when you work with serverless technologies is just how rapidly you can build an application. So as an example, the emergency department digital integration piece we did for the NHS, they approached us in the August and said, can you build us a booking system for our emergency departments? And within 13 weeks, we delivered a 24/7 operation, blue-green deployment to production in a national rollout. And that was built on Lambdas and Aurora DB. So I think it's the speed with which you can create things, and when you get out, when you release the platform and you're not worried about the platform, then that kind of rapid development becomes a reality.
Yeah, and that's super exciting, isn't it? It's like what we were talking about, accelerating, going out and playing, doing some little home projects, but we're also talking about building national infrastructure here with this very same tech. And doing that at speed, and that is what's super exciting. And I think even this last week, I've been bidding on an energy project, and the initial ask was spec'd out by the client using sort of microservices, and then we thought, well, actually, why don't we give you like a serverless option, And we worked out the costings of it. And it's like, this is going to save you so much money by using sort of cloud native serverless products rather than doing full-blown microservices, using maybe some of the more traditional microservice technologies, which almost seems funny saying, since I was only preaching about microservices as a new thing 4 or 5 years ago, but already we're moving on and embracing a new world. So that's super interesting. And I was just thinking over your talk, Chris, it's like, I think a lot of people here, and I know myself at times, have been slightly overwhelmed by how many services there are. And Ryan's joining us on the call as well. And Ryan, how do you go about sort of knowing what services to start with before I ask Chris that very same question?
Thanks, Rich. I appreciate that. And thank you for hosting this session. And thanks to Chris and the rest of the panelists. I started really my IT journey back in 2015, in the hopes of being a software developer. Quickly changed to solutions architects once upon a time. Actually, Chris, former Amazonian as well. So going down that road, so making these evolutions with many of our clients and our customers, and learning. One of the best ways I find is just start with what you know, or start with what you're curious about. There's so much out there, for any one cloud stack, and go with what's most comfortable. For me, starting out, software development, so learning about the SDKs, learning about the different platform services that are able to get applications out quickly. That was an easy entry point for me. For others that are more kind of cloud native, it could be with Lambda. I've had conversations with clients about wanting to start, maybe they're having an innovation lab or some sort of R&D team, and starting kind of a net new application, and Lambda is a good use case for that, right? And so, experimenting with that. If I'm being completely honest, not everyone's ready for Lambda too. I think there's a learning curve that goes with that, and how to integrate that into architecture. So I think that's where I call it having as many on-ramps to learning as possible, right? And so if you imagine that freeway of learning, having many avenues of learning, having an organization, having a team that's supportive of it. I think several of you mentioned experimenting in those environments. So allowing teams to test and try is really, really key, especially for new technologies, and being allowed to sometimes and oftentimes fail in that discovery is actually key as well. There's a lot of learning that goes with that. So start with what you know, and what you'll find is, you'll start to kind of leapfrog into other services and other ways of growing that knowledge. So that would be my best advice.
Yeah, that's great. Would you agree with that, Chris? Is that sort of how do you approach it, or would you kind of draw a flow diagram first?
I would always try it for sure. I guess the keys are try them quickly, but then test at scale as well if performance is going to be the issue. But that's the key difference, that it doesn't take 3 months to procure the infrastructure to try this stuff, and then if you've made a mistake, you have to start from scratch again. It might take an afternoon and follow through some workshops. You'll get a feel for the nuances of how these services work, because there are a lot of services overlapping, especially Amazon will often have, or AWS will often have a native service that we've developed ourselves, and then we find in the industry, developers start to love a particular thing like Kafka, for example. So we'll then take that on as a managed service as well. But that overlaps quite clearly with Kinesis, for example. So it really depends, and in some cases there is no right answer. Right, either would do fine, but the key is that you've tested it functionally, you tested at scale to make sure it will work in your particular use case, and just make the decision and move on. And the key is that if you can iterate quickly, then it's what we call in Amazon an open a two-way door. Sorry, we have one-way doors and two-way doors. And I think what has happened in technology over the last couple of decades is we've moved from going through these one-way doors where you make a big decision, you're stuck with it for 2 or 5 years, to the situation where you can make a decision and you're stuck with it for 5 minutes. You just kind of, okay, well, I'll put that down to experience, make a cup of coffee and start again, try something else. That's the main thing. And often, as I said, it won't be that, there will be overlapping services. The thing that I struggle with personally at the moment is the developer frameworks. I find that there's no one perfect framework or accelerator that works for everything I'm doing. I'm working in IoT and it encompasses serverless and front end and lots of back end stuff as well. And I always seem to be ending up in CloudFormation, whichever I choose. So, neither SAM or Amplify or CDK. CDK will do it all, but I'm still waiting for the one tool to master it all.
Yeah, I know what you mean. And I was playing with Amplify over the weekend, and there's just like so many different docs, and they've been written over time, and blog posts that, even 2 years ago are already out of date, and, using old libraries and whatnot. But I think I just cracked open Terraform and kind of built from Terraform, and that was a little bit easier in that case. But, everyone's mileage is going to vary. But what's really interesting is it's almost like that spirit of discovery and that something that comes along with investigating this stuff. So that's super exciting. And also, I do want to just warn people, do watch your usage, do know what is available on the free tier and what isn't. You can get burnt by spinning up a bit of a Databricks instance on Azure and realizing it's running several large compute instances underneath it, and you're being charged for them. So to do there is a slight caveat there. Use it responsibly, folks. You don't want a £26,000 Amazon bill, but the free usage tier is actually quite generous on all these platforms. I think we can agree. Mm-hmm. So I just want to start wrapping up now, and really apologize for doing so, because this is like super fun conversation. I could talk about this for the next hour or so. And I know we've only advertised it to end at 6:30. So we will start wrapping up, but there's one question that I do want to ask each of you, each of our panelists. What services out there are you excited to either one, use like a whole heck of more from now on because it's just fun, or is there some services out there that you're just itching to get your hands on and start playing about with? So I'll start with you, Tim, if that's okay.
Yeah, well, personally, I mean, it's obviously a subjective view, but some of the ML and AI services in Google Cloud particularly are absolutely sort of world class, and I think they're doubling down at the moment on trying to improve the developer experience, and also actually to sort of smooth off a lot of the rough edges between working with all of these different tools and APIs. And so they recently, earlier this year, released a tool, effectively a platform called Vertex AI, which tries to address some of the pain points in ML ops to smooth out pipeline problems and hassles, and effectively reduce the amount of time you're spending composing these architectures to actually train your models and get some insights and commercial results that actually your users and your stakeholders are interested in. So that's one thing I particularly like to look at. I think the other area, just quickly, would be, recent years have seen some really interesting new platforms coming out which build on top of AWS, things like Begin or Vercel or Netlify, where again, they're focused on speed of iteration, producing results quickly, supporting a lot of interesting technologies like Jamstack and such like. That's an area as well I'd like to sort of dip into and have a look at. Yeah, it's great stuff. Thank you. Mike Winter.
Yeah, so the three for me, Azure Arc, AWS Outposts, and Google Anthos. I really like the idea of this kind of unification of the platforms, the including of on-prem, making that standard. It just decreases, it decreases onboarding time, increases your delivery times. Everybody understands a kind of unified way of doing things, and it makes the people who work on those projects happier that the skills that they're learning A, it's within their skill set, and B, it's not a throwawayable entity. So they're not working on some, on-prem technology that they'll never use again in future.
Yeah, awesome, cool stuff. Ryan.
I'd echo everything that has been said. For me, I definitely, lean more towards the AWS side, but that for me, the exploration now is across Azure and Google and seeing what their capabilities lie, particularly in the area of machine learning, analytics. I'm, very curious about, and I'm kind of sitting on emerging technology these days. So I'm interested in satellite. The use of satellite data is another one. Talking about, and Chris might be familiar with this, ground station as a service. So that's an interesting area for me. And then, of course, the evergreen conversation around data security and data governance. I think that always kind of piques my interest. And so seeing some of the things that are being done around provable security, which is quite interesting. So I think on the AWS side, there's like IAM Access Analyzer and other bits with Inspector that are doing that. Macy is another one. So just playing around with some of those services that help with, or at least help facilitate that conversation around data security and governance.
Awesome, thank you. And Chris, I know I asked you this earlier. So what would
I've changed my story.
Oh, again, you changed it even when we were talking earlier. But so no, that's all good.
It's innovation, isn't it?
Yeah.
I'm really looking forward to exploring Proton a bit more. I only really discovered it that it's GA'd recently, made generally available. So I want to have a look at what that can do for developers and speed up the creation of environments and services for that. But my passion is IoT. I've been also spending quite a lot of time in machine learning as well. So I'm currently up to my elbows in a technology called Greengrass version 2, which is a system to run IoT components on Linux-based systems, but it enables you to deploy code out to vast fleets of devices. So I've moved from treating servers like pets to treating them like cattle to getting rid of them completely on serverless. But now I've my Raspberry Pis and my pets again.
Nice. Yeah. Well, with Amazon's latest release of their product this week, the little robot, I'm sure it won't be long until we're just programming our pets to love us. And yeah, that's quite good. It gives me that warm, fuzzy feeling that somebody will love me, even if it's a machine that I've programmed myself. But yeah, but thanks so much to all of our panelists and of course our speaker Chris, and hopefully it's given you some inspiration. As soon as I start talking about this stuff, it's like, actually, I want to crack this stuff open and have a further play. So hopefully you can go away with that feeling. Please don't be shy of these services. If you do have any questions, I'm sure Chris would love to answer, as well as anyone else on our panel. You know, they've been tagged in LinkedIn and all the rest of it, and I'm certainly about on LinkedIn. So we'd certainly love to hear stories. Show us some amazing innovation. That's what would be really good to carry on into the next year or so. So thank you all, and we will wrap up there.